Hello everyone, welcome to Maths IEC. The difference between average velocity and instantaneous velocity is something that students always get a little confused about. So in this video, I'm going to quickly explain the difference. By definition, average velocity is the total displacement divided by the total time. Now, if you think about an object starting to move from here, let's say it moves like that, goes down, stops here for a while, and then eventually comes, and then this is the end point. This is the starting point, this is the end point. Now, let's say the time taken for the journey is t. Now, when you find the average velocity, we only need to know the displacement, which is this one here, the straight line. So, total displacement divided by total time gives you the average velocity. Now, let's look at another important thing. Now, let's say if a person starts to run in a circular path like this, and this is the starting point. The person runs and completes one whole round and ends the journey at the same point. Now, the average velocity for his motion is actually 0. Why? Because the displacement is 0 divided by some time. The answer is still 0. Now, this is something that most people kind of struggle with, because after completing all this motion, how come the average velocity be 0? Well, because the total displacement is 0, 0 divided by whatever the time, the answer is still 0. Now, here are some important points you need to remember. In average velocity, we only consider the overall change in the position, not the path taken. So the path taken could be a circle, could be any random shape, doesn't matter. It gives the overall rate of change of position. So which you understand, in the circular situation, the overall change of position is 0. Hence, the average velocity becomes 0. So average speed is total distance, which is a scalar quantity, divided by the total time. Now, in this case, it depends on the distance and not displacement. So the idea is, it gives you how fast something was moving on average over a given journey. So when you calculate average speed, you need to even take into consideration the time the object was stationary along the way. So for example, if you are finding the average speed for a journey from point A to B, and if you are kind of, let's say a car journey, and then you've stopped at a red light for a minute, you don't really worry about that. You just look at the time at the beginning when you start the journey, and at the end of the journey, you just get the total time, and then you look at the total distance, not displacement, the actual distance, and then you just divide distance by time. Let's look at this question to properly understand this. A particle is moving in a circular path, horizontal circular path, at a constant speed of 8 meters per second. As you can see, the radius of the path is 2 meters. So I have marked 3 places. It starts from A, then it goes to B, then to C, then all the way around back to A. So I want you to work out the average speed and average velocity at point B, at point C, and at point A, but after completing one cycle. Please pause the video and give this a try. Then play the video when you want to check the answers. We know the average speed of this particle is 8 meters per second. It's going at 8 here. Here also it's going at 8 meters per second. Here it's going at 8 meters per second like that. And it comes back to this point. The answer for the average speed, here it's 8 meters per second. Here is also the same. And that one is really easy. That one is 8 meters per second because it's constant. But what about average velocity? Now we need to consider each point separately. If you consider the movement from point A to B here, to get average velocity, we need to find the total displacement and you divide it by total time. Now, how do I do that? The displacement, so I know this is 2 meters. This is 2 meters. Obviously, I can use Pythagoras theorem to work out this one, which is 2 squared plus 2 squared square root, which is root 8 meters. So I know this is root 8 meters. So I know the total displacement as root 8. But what about the total time? Oh, that's actually not too difficult to do, because I can find the time taken to complete one cycle. You can write the equation speed is equal to distance over time. I know the speed is 8 meters per second because it's a constant speed. Distance. Now the distance is basically the circumference of this circle. So the circumference is 2 pi r. Right? Now the radius here is 2 divided by this time here is actually the periodic time. Periodic time is the time it takes to complete one cycle. So let's do this one. So the time is 2 pi, radius, we know it's 2, divided by 8. So here we know the periodic time is 1.57 seconds. Now, what is the time taken for this motion here, which I just highlighted in yellow? It's obviously quarter of the periodic time. So all I need to do is divide the value of t by 4. So I can see it takes 0.3926 seconds. Periodic time divided by 4 is 0.3926. Now I'm going to substitute it here, and I can see the average velocity is 7.2 meters per second. And what is the direction of this? The direction is this way here. If you want, we can work out this angle, which is 45 degrees, because this is an isosceles triangle. The direction is along this red line. Now, let's think about point C. We need to find the average velocity. So what we need to do is, we need to find the total displacement to divide it by total time. Now, the displacement is very easy because we start from A and the path doesn't matter, we end up at C. So we can see the displacement is 2 meters there, 2 meters there, that will be 4 meters. So to get the average velocity, I need to divide total displacement, which is 4 meters, divided by the total time. Now, we already figured out earlier that the periodic time, or the time it takes to complete one whole cycle, is 1.57 seconds. Obviously, half of that is what it takes to complete half of that, which is from A to C. So half of 1.57 is 0.785. So the average velocity at point C is 5.1 meters per second. Now the direction is from the starting point to end point, so it is vertically downwards like that. Now, after completing one cycle, average velocity is obviously total displacement divided by total time. Now, the total displacement is 0, so the time is 1.57. The answer here is 0. The next thing you need to know is instantaneous velocity. So by definition, this is the velocity at a specific instant in time. Now it tells you how fast and in what direction an object is moving at a given moment. On a dt graph, you can find this using the gradient of the tangent at that point. If you think about an object traveling in a circular path, at this point, here's the direction of the velocity. What about the instantaneous velocity at this point? Is that way. What about at this point? Is that way. What about this point? That way. So it is continually changing. So imagine an object takes some random path like that. So instantaneous velocity at that point is this way. At this point, it's that way. At this point, it's horizontal like that. So like that, it can change at any given instant. So for average velocity, that doesn't matter. All we look at is where did we start, where did we end, and you just get the total displacement, which is the length of this red line, and you divide it by the time taken. Here's another question for you to try. This is a really interesting question. I have seen very similar questions in previous A-level past papers. It's a slightly tricky, it's a bit harder than it looks. Many people assume that the average speed of the car for the whole journey must be the average of 40 and 30, which is 35, like 40 and 30 is 70, half of 70, 35. But that is not the case. I can tell you the answer is not 35. Pause the video, write the question down, and give this a try. When you want to check the answer, press play. Now let's have a look at this question. A car travels from point A to B at a speed of 40 meters per second. So this way it's 40 meters per second. And returns immediately at 30. Okay. And then it turns back and then comes at 30 meters per second. The moment we see that, we can clearly understand that the time it takes to go is T1. The time it takes to come back, we have to call, say, T2. It is different. Obviously, when you are traveling at 40 meters per second, it takes shorter. So T1 is actually smaller than T2. But the point is they are different. The question is, calculate the average speed of the car for the whole journey. Now, the reason why most students struggle with questions like this is because they are like, I don't know the distance. How can I calculate it? Well, if you don't know the distance, let's assume that to be d. To get the average speed, let's write the formula. So we know we have to find the total distance and divide it by the total time. Now, how do I do that? The total distance is d to go from A to B, and it comes back immediately. So that's another d. So the total distance here is 2d. Total time is T1 and T. Now let's see what we can do. Let's think about each journey separately. When you go from A to B, we can write the formula speed is equal to distance over time. So 40 is equal to d over T1. Now for the return journey from B to A, speed is equal to distance over time. Now 30 is equal to d over T2. Now to simplify this, I'm going to make T1 the subject from the first one. So I get T1 is equal to d over 40. And then I'm going to make T2 the subject from the second one. So T2 is equal to d over 30. Now all I need to do is substitute the value of T1 as d over 40 and substitute T2 as d over 30. So now 2d over T1 is d over 40, T2 is d over 30. Now let's simplify this one. That is 2d over LCM 120 divided by 40 is 3. So that will be 3d add 4d. That will be 2d times 120 over 3d add 4d gives you 7d. Now the 2d's gets cancelled out. The answer is 240 divided by 7, which is 34.3 meters per second. Now there's another way to do this same question. It is much shorter. So I'm just going to tell you how to do that. Here we don't know the distance. So instead of assuming d, we can actually assume a value for it. Now let's say if I have the freedom to choose any value for the gap between the two, I'm going to go with 120 meters. Now why did I choose that? Because I can clearly see I can divide that by 40 and 30, then I get nice round answers. I can assume anything, I get exactly the same answer even if I assume this distance to be like 51 kilometers or something. Doesn't really matter, but I'm just going to make it easy for me. If I take the distance to be 120, what is the total distance? 120 to go, 120 to come back. That will be 240 meters. What is the time taken? 120 meters at 40 meters per second. That would obviously take 3 seconds. 120 divided by 40 is 3. And T2 is 120 divided by 30 is 4 seconds. And 3 seconds to go, 4 seconds to come back. That is 7 seconds. And this is exactly 34.3 meters per second, just like we got before. This is much shorter and it works just the same way. Now, if you think about why this method works, because if you remember in the previous calculation, the d at the top, and the d at the bottom eventually got cancelled out. So it doesn't really matter what the value of d is. Now, here's something you can do to properly understand the fact that the value you assume for d doesn't matter. So let's assume a different value for d. So I'm just going to go with 360 meters. So you can pause the video here, use 360 and do the calculation. And you should get 34.3 as the answer. And then play the video to see how I do it. 2D, 2 times 360 is obviously 720 meters divided by T1. Now, 360 divided by 40 is 36 divided by 4, 9 seconds. And for the return journey, T2 is 360 divided by 30, that is 12 seconds. Now, the total time taken is 9 add 12, that is 21 seconds. And when you divide 720 meters by 21 seconds, you again get 34.3 meters per second. And it proves that irrespective of the value you assume for the d, you get exactly the same answer in these type of questions.